Hi everyone, how are you all? So in this lecture, we will study functional dependency. This concept we will study in this lecture. So let's start. So let's see what is this functional dependency. This is another type of integrity constant. We have already seen many different type of integrity constants, like a referential integrity constant. We have seen what is I can say entity integrity constant, domain integrity constant. So this is another integrity constant that we need to study, that is functional dependency. Okay, so you can see this is another type of integrity constant defined on the schema. Now let's see what is this functional dependency. So let's start with one example. Consider some school database, okay, some Indian school database you consider, in which you have a table, a student table. In this student table, let's assume you have a student ID, a student name, district, state. So these are the attributes in this table. Now you tell me one thing. So this is your student table. This is the student table. In this student table, you have a student ID, you have a student name, okay, and there is a column district, there is a column district, and there is a column state. Okay, so in this relation, you tell me if two districts are same. For example, if let's assume if I put alpha here and if I put alpha here, okay, if districts are same, means in these two tuples, let's assume this is your tuple T1, let's call it tuple T1, and let's call it tuple T2. Okay, now you tell me, if in these two tuples, if district name is same, then can you guarantee that this state name will be same? Please tell me, can you guarantee that state name should be same? Can I say that this state name also should be same? Please tell me. In these two tuples, there is a tuple T1, there is a tuple T2. In these two tuples, if district name is same, then can I say state name should be same? Yes. Yes or no? If district name is same, for example, I can say if Jaipur, Jaipur, then what should happen? You can see state name should be same. Yes or no? So I should put Rajasthan here. Okay. So this is what I'm saying, that if you repeat the district name, I can say in two tuples, if district name is same, then state name should be same. Yes or no? So I can say that these also must be same. Do you agree with me? Okay. This is called functional dependency. That if I tell you the name of the district, then automatically you can tell me the name of the state. This is called functional dependency. Okay. For example, if I tell you the name of the district, okay, means for example, I say Mumbai, then what will be the name of the state? Please tell me. If I tell you the name of the district, then you can tell me the name of the state. The name of the state will be Maharashtra. So you can see one thing. I am telling you the value of this column. I am telling you, but you can determine the value of this column. Do you agree with me? Yes or no? If I tell you the value of this column, if I tell you the value of district, then you can determine the value of state. Yes or no? Okay. So very simple point, that if you know the value of district, for example, if you know that district is Mumbai, then the state name will be Maharashtra. Yes or no? Okay. So is this clear? Please tell me. So very simple point, that I can say this district, this determines state. Yes or no? Okay. What I can say this district, this column, this attribute determines this attribute. If you know the value of district attribute, then you can find out the value of state attribute. Okay, so I can say this district attribute determines the state attribute. Yes or no? Now tell me, can I say state attribute determines district attribute? For example, if you know the name of the state, okay, for example, if you know the name of the state, now can you tell me what is the name of the district? Can you tell me? No, you cannot tell me. Also, another question. For example, if I tell you that here the state name is same in these two tuples, okay, there is a tuple T1, there is a tuple T2. This is your tuple T1, this is tuple T2. In these two tuples, I am telling you that state name is same. Then tell me, can I say district name must be same? Please tell me. In these two tuples, can I say district name must be same? They may or may not be same. Yes or no? They may or may not be same. For example, this may be beta, this may be gamma. Do you agree? Okay, so they may or may not be same. So this is what I'm saying, that can I say state, this state column, if I tell you the value of state, then can you determine the value of district? No, you cannot determine. Yes or no? So I can say this state determines district. This statement is wrong. Yes or no? This statement is wrong. Okay, I hope you understood what is functional dependency. So remember here what is happening. Here I can say if you know the value of this column, then you can find out the value of this column. So I can say this column, district column, determines the state column. Okay, or I can say in two tuples, if you have same district value, in two tuples, if you have same value for district, then in those tuples you will have same value for state. Yes or no? So this is the complete idea. So I can simply say that district implies state. Okay, yes or no? I can say that district, if you know the value of district, then that implies state. Then you can also find out the value of state. So I can say district implies state. Is this clear? Please tell me, is this understood? I can say district determines state. I can also say that district determines state. Determines state. Okay. Now, what is the definition? What this means? This means that in all the tuples, for all tuples T1, T2, if I give you tuples T1, T2, remember T1, T2, these are the tuples. For all tuples, what I can say that if see, in all tuples I am saying, for all tuples I am saying that if in these tuples district value is same, in these two tuples, if district value is same, then what should happen? Please tell me. In these two tuples, if district value is same, if T1 district is equal to T2 district, then what should happen? Then I can say T1 state, that should be same as T2 state. Yes or no? So in two tuples, if district value is same, then in those two tuples, state value also must be same. Okay, so this is the definition of functional dependency. I can say that this state is functionally dependent on district. Okay, what I can say? I can say that this district functionally determines state. Okay, this district functionally determines state. Functionally, okay, determines state. So you can see this is the idea. Functionally determines state. I can also say that state is functionally dependent on district. I can also say the same statement. I can also say that state is functionally dependent on state, on district. Dependent on district. Is this understood? See, this is a very obvious thing. I can say very intuitive thing. Okay, you can see if you know the value of district, then you can find out the value of state. I can say state is functionally dependent on district. This is what we will say. We will say that state is functionally dependent on district. What it means? It means that in two tuples, if district value is same, then in those tuples, state value will be same. Okay, so this is the idea. So remember, all these statements are same. Read these statements, all of them are same. Okay, so you can see district implies state. This statement is same as district functionally determines state. This statement is same as district determines state. Or I can say state is determined by district. I can also say state is functionally dependent on district. I can also say state is dependent on district. So you can see all of them, these statements, all of them are same. Okay, all these statements, you can see all these statements, they have the same meaning. Okay, and we will denote it like this. All these statements, remember, they are same. All of them are same statements. Okay, and how do we denote it? We denote like this, that district implies state. This is how we denote. Okay, this is how we denote. So I hope you understood. This is the idea of functional dependency. This means that state is dependent on district. Okay, you can see this line. State is functionally dependent on district. Okay, so this is the idea. I hope you understood. Now let's see some more examples. Please tell me, if you know the IFSC code, then can I say you also know the bank name? Means if I give you the IFSC code, If I tell you the IFSC code, then can you determine the bank name? Can you determine the bank name? Please tell me. Can I determine the bank name? If you know the value of IFSC code, then can you determine the bank name? Yes, you can determine. See, I can also say that in two tuples, if IFSC code is same, let's assume this is your tuple T1, this is your tuple T2. Now tell me, here IFSC code and here IFSC code, they are same. Okay, let's assume here also A, here also A. Then can you guarantee that in these two tuples, bank name will be same? Please tell me. In these two tuples, remember T1 is a tuple, T2 is a tuple. These are tuples. Okay. Now in these two tuples, if IFSC code is same, then can I say bank name will be same? Yes, bank name will be same. Yes or no? This will be same. So this is the idea. Okay. So this bank name, this also will be same. I can say BB. Okay. So this is the idea. Now tell me, if you know the bank name, then can you determine the IFSC code? Please tell me, if you know the bank name, if I tell you the name of the bank, now can you determine IFSC code? Can you determine IFSC code? No, you cannot determine. Yes or no? Okay, yes or no? No, you cannot determine. So this you cannot determine. Very simple point. Okay, because you can easily see, for example, if you have SBI bank, okay, in these two tuples, you have SBI bank. This is your tuple T1, this is your tuple T2. In these two tuples, you have SBI bank. Now, it does not mean that IFSC code will be same. Okay, here you can have some other IFSC code. Here you can have some other IFSC code. Yes or no? Maybe here you have something called maybe SBIN 0012. Okay, or maybe here you have something called SBIN 0034. Yes or no? So is this clear? So you can see, if you know the name of the bank, you cannot determine the value of IFSC code. But if you know the IFSC code, if I tell you the IFSC code, then you can determine the value of the bank. Okay, so this is the idea. Now, can you give me a situation where, can you give me this type of situation? Can you give me that A does not determine B and B does not determine A? Means A does not determine B and B does not determine A. Can you give me this type of situation? Give me this type of situation. Give this type of situation. Can you give me where A does not determine B and B does not determine A? For example, name comma marks. For example, you can say name, you can say A name and B marks. B you can take marks. Now tell me, if marks are same, if two people have same marks, then can I say they have same name? Please tell me, if two people have same marks, can you say they have same name? So you can see name and marks. Okay, in two tuples, if I put same name, okay, let's assume in these two tuples, I am putting same name. Here also I am putting John. Here also I am putting John. Now, is it mandatory that they have same marks? See, these are two students. These are different students. This John is different. This John is different. Now, can I say they will have same marks? No, they can have different marks. They can have different marks. Now you tell me, if I put same marks in these two tuples, if I put same marks, then can I say the student name will be John? Can you guarantee that student name will be John? Please tell me, can you guarantee that student name will be John? No, you cannot guarantee. Maybe student name is something else. Yes or no? Maybe student name is Sonu. Okay, so this is the idea. I hope you understood. Okay, so you can see this is the situation where A does not determine B, B does not determine A. If you know the value of A, then can you determine the value of B? No. If you know the value of B, can you determine the value of A? No. Or you can see in these two tuples, the value of A is same. This is your A. This is your B. In these two tuples, value of A is same, but value of B is different. In these two tuples, value of B is same, but value of A is different. Okay. So I hope you understood. Is this clear? Can you give me a situation where A determines B and B determines A? Can you give me this type of situation? Can you give me this type of situation where A determines B, B determines A? This type of situation, can you give me? Can you give me? A determines B, B determines A. Yes, for example, A can be your Aadhaar card number. A can be your Aadhaar card number. Let's assume this is your Aadhaar number. And maybe B is your PAN card number. Yes or no? Is this clear? So can I say A determines B, B determines A? Please tell me. For example, if you have, let's assume this is your Aadhaar card number, this is your PAN card number. Okay. Now you tell me, if two people in these two tuples, if I put the same Aadhaar card number, then can I say they will have same PAN card number? Please tell me. In these two tuples, if I put same Aadhaar card number, then can I say they will have same PAN card number? Yes, they will have same. They cannot have different PAN card, right? Yes or no? In these two tuples, if I put same Aadhaar number, then you cannot have different PAN card number. So I can say they will be same. Yes or no? Similarly, if I put, for example, if I put same PAN card number in these two tuples, if I put same PAN card number, then Aadhaar card number also will be same. Are you getting my point? So this is the situation where A determines B, B determines A. Okay. I hope you understood. Is this clear? Please tell me. Is this understood? Okay, so this is the concept of functional dependency. Now, let me tell you the definition of functional dependency. You already understood what this means. Functional dependency. This means that if A, B are attributes, A is attribute, B is attribute in a relation R, then when can we say A determines B? When can we say A determines B? A implies B. A determines B if and only if whenever two tuples have same A value, then those two tuples must have same B value. Yes or no? Read this definition. A, B are attributes in a relation R. There is a relation R. In this relation R, let's assume A is an attribute, B is an attribute. Okay, there can be more. Now, when can I say that A determines B? What is the meaning of A determines B? A determines B. First of all, this, how do we read it? We read it that A determines B. This is how you read it. A determines B. You can also read it A functionally determines B. You can also read like this. A functionally determines B. Okay. This is how you can read. A functionally determines B. You can also say that B is determined by A. Okay. You can also say that A implies B. All these are same. I already told you that all these are same. You can also say that B is functionally dependent on A. Yes or no? B is functionally dependent on A. Okay, so like this. So these are different interpretations. So what this means? This means A determines B. Now, when can I say A determines B? A determines B if and only if whenever two tuples have same A value, then those tuples must have same B value. Yes or no? Whenever two tuples have same A value, then they must have same B value. Okay, so this is the idea. So what this means, remember, you have a relation R in which you have attributes. For example, A, B, C, D, these are the attributes. Now, what the definition of A determines B? This will happen if and only if. For all tuples. This will happen if and only if for all tuples. For all tuples T1, T2. This T1, T2, what are these? These are tuples, remember. This T1, T2, these are tuples. Okay, so these are tuples. Now I am saying that for all tuples, what should happen? For all tuples, this should happen that if these tuples have same A value, okay, this T1 A is equal to T2 A. If these two tuples have same A value, then what should happen? Tell me. If these tuples have same A value, these tuples, they have same A value, then they should have same B value. Yes or no? These two tuples have same A value, then what should happen? This should happen that they have same B value. Okay, this T1 B is equal to T2 B. They have same B value. So I hope you understood. So this is the idea. This is the definition of functional dependency. Okay, and how do you read it? You can read that A determines B. Okay, so this is the definition. I can say A determines B if and only if T1 dot A is equal to T2 dot A. This implies, okay, remember, this means that two tuples have same A value, then what should happen? This should happen that they should have same B value. They should have same B value. T1 dot B is equal to T2 dot B. They should have same B value. For all tuples, this should happen. This should happen for all tuples T1, T2. Okay, whatever tuples you take, if they have same A value, then they must have same B value. So this is the definition of functional dependency. I hope you understood. Okay. So is this clear? Please tell me. So you can see the definition of functional dependency we have seen. Now, one important note I want to tell you. That is, functional dependencies are defined on the schema. They are not defined on the instances. Remember, functional dependency, these are defined on the schema. Do you remember I told you that integrity constant, they are defined on the schema? Yes or no? When we were discussing integrity constant, for example, referential integrity, for example, your entity integrity, domain integrity, key constant, basically all the integrity constant that we have seen, I told you that they are defined on the schema. All of them, they are defined on the schema. They are not defined on the instances. They are defined on the schema. So all the instances must satisfy them. Yes or no? You are defining this functional dependency, you are defining on the schema. Now what should happen? All instances must satisfy them. Okay, every instance must satisfy them. Is this clear? Please tell me. Now, tell me the answer for this question. In a school database, can we say that s.name determines s.marks? Please tell me. The answer is no. You already know the answer is no. Yes or no? Okay, the answer is no. So very simple that in a school database, s.name cannot determine s.marks. But now consider this situation. One day you are taking test. Okay, you are taking this quiz. Let's assume this is your weekly quiz 30. Okay, let's assume this is your quiz 30 in this school. I am talking about this school. In this school, one day you conduct this quiz 30 you conduct, and let's assume this type of result you get. Let's assume in this school this happens. Just consider this situation, that name marks. Okay, this happens that these two students, remember these are different students. For example, let's assume this is student ID 100, 101, 102. Okay, let's assume these two students have same name AA. Okay, but their marks are also same. Their marks are also same, let's assume. Okay, and let's assume here you have B and here you have 40. Now you tell me one thing. Is this possible? Just tell me this point. Let's assume in this school only 3 students are there. Let's assume in this school only 3 students are there. This is the situation. In this school only 3 students are there. Now you tell me, first of all, you tell me, is this possible? This type of situation is possible, right? Yes, of course, this is possible. So what we call it? We can call it instance. Yes or no? What we call it? This is called instance. Do you agree with me? We can call it instance I1. Let's call it instance I1. Yes or no? Now you tell me, in this instance, on this particular day, what will happen? On this particular day, let's assume there is another student. Let's assume there is another student. Okay, that student has the name A. And let's assume that student also has 30 marks. Now you can see what will happen. If this happens, then what people will say? People will say that in this quiz 30, if you are having same name, then you are having same marks. Yes or no? People will say this. Do you agree with me? Yes or no? So you can see what people will say. People will say in this quiz means, okay, for this instance, what they will say, if you have same name, then you have same marks. Okay, like maybe you have seen on the Twitter, on the social media, when World Cup matches are going on. Okay, what people will say? People will say that in 1992, Pakistan lost many matches. Still, Pakistan won the World Cup. This year also, Pakistan lost many matches. So this year also, Pakistan will win the World Cup. Yes or no? This type of statements you can see. Yes or no? So this type of statement, they are instances. Do you agree with me? They are instances. So please understand that, like, for example, on a particular day, like this quiz you are holding, okay, you are conducting this quiz, and coincidence, this is a coincidence. Can I say this is a coincidence? Please tell me. Can I say this is a coincidence? Yes, this is a coincidence. Yes or no? So by coincidence, this happens that, let's assume whenever you have same name, then you have same marks. Okay, but tell me on other day what will happen? For example, on the next day, in this quiz 31, what will happen? What can happen in this next day? What can happen? For example, this can happen that this student is getting 50 marks. Okay, so now on this day, can I say that if you have same marks, if you have same name, you have same marks? Please tell me. On this day, can I say? Please tell me. On this day, can I say that if you have same name, you have same marks? No. So this is your instance I2. This is your instance I2. So now you tell me. One day, if you visit this school, you are visiting this school on this day. Okay, this is a coincidence. You visit this school on this day. Okay, and you see this chart, this result you see. After looking at this result, will you say that in this school, if you have same name, then you have same marks. Will you say this? This type of statement will you say? Let's assume you visit this school. Okay, just consider this situation. You visit this school. Okay, so consider this scenario. Let's assume you visit this school on this same day, on this quiz 30 day. Okay, this quiz 30 day. Now you tell me, will you say that in this school, I'm talking about school, will you say that in this school, whenever you have same name, then you have same marks? Will you say this? No, you will not say this. Yes or no? But you can say, what you can say? You can say in this weekly quiz 30, if you have same name, then you have same marks. Yes or no? That you can say. Agree with me? You can say that in this weekly quiz 30, if you have same name, then you have same marks. That you can say. So please understand that if you visit this school on this day, then what you will say? Then which statement is correct? Then this statement is correct, that in this quiz 30, same name implies same marks, or I can say name implies marks. Yes or no? Name implies marks. Means if you have same name, then you have same marks. Agree with me? This statement is correct or not? Please tell me. This statement is correct or not? Just tell me this point. In this quiz 30, I am talking about quiz 30. I am saying in this quiz 30, if you have same name, then you have same marks. This statement is correct. Okay. Now you tell me, is this statement correct that in this school, will you say that in this school, if you have same name, then you have same marks? Will you say this? Please tell me. Will you say this? That in this school, if you have same name, then you have same marks? No, you will not say this. Yes or no? This you will not say. Agree with me? This statement will be false. Yes or no? Is this clear? This statement will be false. So please tell me, did you understand what I'm saying? So this is the point. Remember, this is the important point, that functional dependencies, these are defined on schema. They are not defined on instances. Is this clear? Okay. Is this point clear? Please tell me. So functional dependencies are defined on schema. They are not defined on the instances. If you say that some functional dependency is there, then that should be satisfied by all the instances. Remember, functional dependencies must be satisfied by all the instances. Okay. Now you consider this school situation. You have a school database, and let's assume on a particular day, this quiz 30 is there. In this quiz 30, if you have same name, then you have same marks. This is a coincidence. So what I can say? I can say in this quiz 30, name implies marks. This is correct. Okay. In this quiz 30, name implies marks. This is correct. But can I say in this school, name implies marks? In this school, can I say name implies marks? This is not correct. Yes or no? Okay. For example, this type of situation can be possible. Next day, you conduct quiz number 31. Now you can notice in this instance, name does not imply marks. Yes or no? Name does not imply marks. Is this clear? In this instance, name does not imply marks. Look at this instance. Name does not imply marks. Here you have same name, but you have different marks. Name is same, but marks are different. Okay. So I hope you understood this point. So very simple point. Remember, can we say that name determines marks? The answer is no. We cannot say, but it might be possible. Yes or no? It might be possible that in a particular quiz, in a particular instance, here this quiz means instance. Yes or no? It might be possible that in a particular instance, S name, if S name is same, then their marks are same. This is possible. Okay. This is possible, but it does not mean that in the school, on the schema, S name determines marks. Okay. I hope you understood this point. So remember this point, you remember. See this. This is an interesting point, that if I give you an instance, given an instance, what I'm giving you? I'm giving you instance. If I give you some instance, then when can I say this instance will satisfy functional dependency? When can I say this instance will satisfy functional dependency? If I give you some instance, when can I say this instance will satisfy functional dependency? Then you will check this instance. You will check this instance, you will check. And in this instance, you will check that if two tuples have same alpha value, then they should have same beta value. Yes or no? Okay. This instance you will check. But tell me, If you check the particular instance, I give you a particular instance, you are checking that particular instance. If some functional dependency is satisfied in that instance, then is it mandatory it will satisfy for the schema? Please tell me. I give you a particular instance I'm giving you. Okay. A particular instance I'm giving you. On this instance, if some dependency is satisfied, if this dependency is satisfied by this instance, then can I say this dependency is satisfied by the schema? No, that is not correct. When can I say schema will satisfy this dependency? When can I say the schema will satisfy the dependency? Schema will satisfy if all instances satisfy. Yes or no? Schema, remember, schema will satisfy. When can I say schema will satisfy? This functional dependency will be satisfied by the schema if all instances satisfy this. Yes or no? Do you agree with me? This functional dependency will be satisfied by the schema if all instances, they satisfy this functional dependency. Okay. I hope this point is clear. Now, let's see this example. Tell me the answer for this question. Tell me one thing. In this question, the question is asking for instance or the question is asking for schema? See, the question is saying consider the relation instance. This instance is given to you. And these are the functional dependencies that are given to you. The question is asking which of these functional dependencies they hold on the instance. The question is asking which functional dependencies hold on the instance. The question is asking for instance. The question is not asking for schema. Yes or no? The question is asking for instance. So now you tell me, for this instance, which functional dependencies are satisfied? Look at this instance and tell me which functional dependencies are satisfied. For example, can I say this is satisfied? This A determines B. Is this satisfied? A determines B. Is this satisfied? This is not satisfied, right? This A determines B. This is not satisfied. Why? What is the reason? You can see here A value is same, but B value are different. Yes or no? Can you notice? If you know the value of A, can you determine the value of B? Please tell me. If you know the value of A, can you determine the value of B? If I tell you the value of A, then can you tell me the value of B? You cannot tell me, because here you can notice here value of A is 0, here also value of A is 0, but here value of B is 2 and here value of B is 3. Yes or no? So you can easily see, if I give you the value of A, can you tell me the value of B? You cannot tell me, right? So can I say that in this instance, can I say in this instance, A does not determine B? Yes or no? A does not determine B. In this instance, A does not determine B. Is this clear? Please tell me. I can say in this instance, I can say that A does not determine B. Okay. If I tell you the value of A, you cannot tell me the value of B. For example, if I tell you the value of A, I'm giving you the value of A. Okay. I'm giving you the value of A. I'm telling you value of A is 0. Now, can you tell me the value of B? Can you tell me the value of B? You cannot tell me. The value of B can be 2 or 3. Yes or no? So you cannot determine, right? You cannot determine. We cannot determine, right? Is this clear? So if I give you the value of A, can you determine value of B? You cannot determine. So I can say this is not, this does not hold. This functional dependency does not hold in this instance. For this instance, this functional dependency does not hold. Okay, is this clear? Let me know. Very simple. What about the next? What about A determining C? What about A determining C? Please tell me. What can you say about A determining C? So A determining B, that does not hold. A determining B, that does not hold. What about A determining C? If I give you the value of A, can you tell me the value of B? Sorry, can you tell me the value of C? If I give you the value of A, can you tell me the value of C? Yes, you can tell me. You can see whenever A value is same, then C value is also same. Yes or no? Whenever A value is same, then C value is also same. For example, if I tell you the value of A is equal to 0, then can you determine the value of C? I tell you value of A is 0, then what will be the value of C? That will be 4. If I tell you value of A is 1, then what will be the value of C? Value of C will be 5. So if you know the value of A, then you can determine value of B. Agree with me? Yes or no? Okay, so I can say that in this instance, this is satisfied. So remember, this is satisfied by this instance. This is satisfied by this instance. Okay. So remember, this functional dependency is satisfied by this instance. Okay. This given instance will satisfy this dependency. Is this clear? Okay. So this dependency will be satisfied. Remember, this will be satisfied by this given instance. This is important, that this given instance is satisfying this dependency. Okay. What about the remaining? Quickly tell me. What about the remaining? What about B determining A? What about B determining A? What about B determining A? Please tell me. This B determining A. This does not hold. If I give you the value of A, give you the value of B, can you give me the value of A? If I give you the value of B, I am giving you the value of B. Now, can you give me the value of A? Can you give me the value of A? You cannot determine. Yes or no? You cannot determine. If I tell you value of B is 3, then can you tell me the value of A? You cannot tell me. So you cannot determine. So I can say this functional dependency does not hold for this instance. Yes or no? Is this clear? What about B determining C? What about B determining C? That also does not hold. You can see that also does not hold. You can check. This B determining C, that also does not hold. If I tell you the value of B, then can you tell me the value of C? You cannot tell me. Yes or no? So this also does not hold. What about C determining A? What about C determining A? Can I say C determines A? Yes, C determines A. Okay, in this instance, C determines A. What about C determining B? What about C determining B? No, C does not determine B in this instance. Is this clear? Please tell me. Let me know. Is this clear? So very simple, right? Yes or no? Now I want to ask you. I'm not asking for the instance. Okay, now I will not ask for the instance. Now I'm asking which of these functional dependencies hold on the schema. Hold on the relation schema. Hold on the relation schema are A, B, C. Now you tell me the answer. Which of these functional dependencies do not hold or hold? Okay, either you tell me hold or you tell me do not hold. So which of these functional dependencies hold or do not hold on this schema? I'm talking about schema now. Now I'm asking for the schema. Okay, I'm only asking for the schema now. So now you tell me. See one thing you notice. In this instance, A determines C. Yes or no? In this instance, A determines C. Yes or no? Please notice. In this instance, A determines C. Correct? I can say in this particular instance, A determines C. Okay, that is correct. But does it mean that in schema this will be satisfied? Does it mean that in the schema this will be satisfied? What you can say? It does not mean that on the schema this will be satisfied. Yes or no? But we can't say for the schema. But we can't say that A determines C or not on schema. On schema we cannot say. Yes or no? Is this clear? Please tell me. On the schema I cannot say, because what can happen? See, this is possible that on some other day what happens, this type of entry comes. Yes or no? See, on some other day maybe this type of entry comes. Okay, so see what can happen. This type of situation is possible that on some other day, okay, some more entries come, some more entries you are doing some more entries, and let's assume this type of situation happens that the value of A is 0 and the value of C is, let's assume, 5. The value of A is 1, the value of C is, let's assume, 6. Yes or no? Is this clear? Please tell me. Okay, is this clear? So you can see in this instance A does not determine C. Okay, in this instance I can say, in this instance I can say that A does not determine C. Okay, I hope you understood. So remember, please understand that this A determines C. This is correct for this instance. In this instance, A determines C. But we cannot say for schema. We cannot say this A determines C, this holds for the schema or not. We cannot say. Okay, maybe this is a coincidence. Do you agree with me? Maybe this is a coincidence that A determines C on this schema. Yes or no? On this schema, A determines C. Maybe that is a coincidence. Okay, so we cannot say that this will this hold for schema. Okay, we cannot say. Okay, I hope you understood. Now, what about A determining B? What about this A determining B? This instance does not satisfy. So can I say schema will also not satisfy? Please tell me. This instance does not satisfy. So can I say schema will also not satisfy? Schema will also not satisfy. Yes, that is correct. Okay, if instance does not satisfy, if this instance does not satisfy, then schema cannot satisfy. Remember, schema satisfies implies all instances satisfy. Yes or no? Schema satisfies, not that some schema. You have some schema. Let's assume I am giving you this schema R. Okay, A, B, C, D, something like that. Now remember this point. Schema satisfies A determining B. Okay, schema satisfies X determining Y. For example, X determining Y. If and only if all instances satisfy. Yes or no? If and only if all instances should satisfy. All instances must satisfy X determining Y. Okay, now you tell me, if some instance does not satisfy, then what you can say? Please tell me. If some instance does not satisfy, if some instance does not satisfy this X determining Y, then what you can say? Then what I can say? If some instance, there is some instance which does not satisfy, then what I can say? Then I can say schema also does not satisfy. Yes or no? Then I can say schema does not satisfy X determining Y. Yes or no? Then I can say that schema also does not satisfy. Is this clear? Please tell me. Yes or no? Is this clear? Let me know. So very simple point. So remember, this instance, this does not satisfy A determining B. In this instance, I can say in this particular instance, what is happening? In this particular instance, A does not determine B. So I can say this schema. Okay, for this schema R, what I can say? So for this schema R, I can say that A does not determine B. Is this clear? Please tell me. So very simple point. Now you tell me, if I say that this schema does not satisfy A determines B, then is it possible that some instance will satisfy? Is it possible? See, schema does not satisfy. Okay, we can say that schema does not satisfy A determining B. But can I say some instance there can be some instance which can satisfy? Yes. Okay, some instance can satisfy, no problem. Okay, is this clear? There can be some instance which can satisfy. For example, this type of instance you have. Let's assume you have this type of instance. You can say this instance will satisfy. Yes or no? This instance will satisfy. Okay. Anyway, I hope you understood all these points. What about the remaining? So you can see for the schema from the instance, what you can say? I can say that for the instance, I can say for the schema, what I can say? For the schema, definitely I can say this does not satisfy. Okay, this does not satisfy. I can also say this does not satisfy, right? I can also say this does not satisfy. What about this one? C determining B. This also does not satisfy. What about B determining C? This also does not satisfy. What about A determining C and C determining A? What about these? They may or may not. Yes or no? See, they may or may not. We cannot say. For these, we cannot say anything. We cannot say anything. Yes or no? For these, we cannot say anything. Is this clear? Please tell me. Because I'm asking for schema. I'm asking for the schema. So for these, we cannot say anything. Is this clear? They may or may not hold in the schema. Okay, yes or no? May or may not hold for the schema. May or may not hold for schema. Okay, so they may or may not hold for schema. I hope you understood all these points. Is this clear? So very simple. So you can see here, for example, this instance is given to you. In this instance, can you see that A determines C? In this instance, can you see in this instance, I am talking about this instance. In this instance, can you see that A determines C? A determines C? Yes. You can notice whenever A value is same, then C value is same. You can see whenever A value is same, C value is same. Whenever A value is same, C value is same. Okay. So very simple point. So in this instance, A determines C. In this instance, you tell me, what about C determines A? In this instance, tell me, what about C determines A? C determines A. That is not satisfied in this instance. You can see C value is same, but A value is not same. Yes or no? Notice C value is same in these tuples. Look at these two tuples. These two tuples. In these two tuples, you can see C value is same, but A value is not same. Okay. So you can see in this instance, C does not determine A. What can you say about the schema? What you can say about the schema? For the schema also, C does not determine A. And in the schema, this may or may not hold. Yes or no? For the schema, I'm asking for the schema. In the schema, this may or may not hold. But I can say in the schema, this will definitely not hold. Yes or no? Is this clear? Please tell me. So I can say in this previous example, what I can say, please tell me. In this previous example, I can say that schema this definitely does not hold for the schema. I can say this C determines A. This definitely is not satisfied by the schema. Okay, this is not satisfied by the schema. Because this is not satisfied by the instance. This is not satisfied by the instance. So I can say that this is not satisfied by schema also. By schema also. Okay. But what about A determines C? What about A determines C? This may or may not hold for schema. Yes or no? This may or may not hold for schema. May not hold for schema. Okay, this holds for the instance. This holds for the instance. For this instance, this will hold. This will be satisfied. But this may or may not hold for the schema. Is this clear? Please tell me. Understood? So very simple. All these points are very simple. Okay. Now let's see another. That is functional dependencies you can define between set of attributes also. So far, if you notice, we have defined functional dependencies. These functional dependencies we have defined so far from attribute to attribute. Yes or no? Agree with me? Okay. So far, this was a single attribute. If you notice, this was a single attribute. So far, this was a single attribute. This was a single attribute. Correct? So far, if you notice, these were single attributes. But remember, this functional dependency you can define between set of attributes also. Okay, between set of attributes also I can define this. So let's see how to define this for set of attributes. For example, let's assume this is your schema. You have a relation R which has these attributes A, B, C, D. Now you tell me what this means, that this set of attributes determines this set of attributes. What this means? Please tell me what this means, that this set of attributes determines this set of attributes. What this means? Because remember, you can define functional dependencies between set of attributes. These functional dependencies you can define between set of attributes. So what this means? This set of attributes determine this set of attributes. So what that means? That means that whenever a tuple, this combination is same. Please understand. This means that whenever this combination is same. Please understand. This combination, whenever this combination is same in two tuples, okay, in two tuples, then what should happen? Please tell me. In two tuples, then what should happen? So remember, whenever this combination is same, this combination must be same in two tuples, then what should happen? Then this C value also must be same in those tuples. Then I can say this C must be same in those tuples. Is this clear? Very simple point. Okay, so this is very simple idea. I hope you understood. Similarly, for example, you tell me what this means, that this set of attributes determines this set of attributes. What that means? Please tell me. This set of attributes determines this set of attributes. What that means? That means that whenever this combination is same, this combination, this entire combination, whenever this combination is same in two tuples, then what should happen? Then what should happen? Then what should happen? Then this BC combination also should be same. Then this BC combination also must be same. Yes or no? Then this BC combination also must be same. Must be same. Okay, understood? Is this clear? Please tell me. So very simple point. So remember, just consider this. You have a relation. This relation you have A, B, C, D. Okay. Now, if I say that AB determines C, what that means? If I say AB determines C, now let's see what that means. This AB determines C. This means that whenever this AB combination is same in two tuples, if I give you two tuples, T1, T2, and let's assume this entire combination is same. This entire combination must be same, remember. Okay, this entire combination should be same. For example, if you put Mn here and Mn here, is the entire combination same? Please tell me. In these two tuples, the AB combination is same or not? Yes, the AB combination is same. Okay, so whenever this AB combination is same, then this C value also must be same. Okay, this C value also must be same. Okay, is this clear? What about this? Please tell me. If I put M here, and if I put, let's assume something else. For example, let's assume if I put P here. Now tell me, let me know. Now is it guaranteed that this should be Q? Please tell me. Are these two tuples having the same AB combination? These two tuples, look at these two tuples. Do they have same AB combination? They don't have same AB combination. They do not have same AB combination. So remember, this may or may not be same. So now the C value can be anything. Now this C value can be anything, no problem. Okay, now this C value can be anything. Whatever you want, you can put. For example, this can be R also. Okay, this can be R also, or this can be Q also. For example, if you do like this, okay, M, and let's assume here you have S, then remember here you can put Q also, no problem. Is this clear? Let me know. Please tell me, is this point clear? Now, let me tell you one thing. That remember, this set of attributes determines this set of attributes. Okay, this you can also write like this: AB determines C. Okay, so remember, these two things are same. Please notice, these notations are same notations. Is this clear? Let me know. Is this point clear? These are same notations. These two things are the same. Okay, but what is the correct one? Like, what is the formal one? I can say, see, both are correct, but this is formal and this is convenient. Yes or no? We do not want to write this and this again and again. Yes or no? We do not want to write this again and again. So for simplicity, we can write like this. So remember, this is a simple notation. I can see this is a convenient and simple notation. I can say this is a convenient and simple notation. Okay. And what is this? This is the actual and formal notation. Is this clear? Okay, so this is the actual and formal concept, I can say. This is the actual concept, or I can say formal concept, and this is convenient notation. So remember, these two things are same. Is this point clear? Please tell me. These two things are same. For example, if I give you that this set of attributes determines this set of attributes. Okay, this you can also write like this, that AB determines BC. Is this clear? Okay, these two things, they are same. Please tell me, did you understand? Okay, both of these are same. Is this clear? So we will use this because, as I told you, this is simple notation. This is more convenient and simple notation. So we will use this. But you should understand what this means. This means that set of attributes AB determines set of attributes BC. Is this clear? What this means? This means set of attributes AB, and this means set of attributes BC. So these two things are same. Okay, so very simple point. So you can see this set of attributes AB determines set of attributes BC. What that means? That means whenever this combination is same, this combination must be same. Okay, so this is the simple idea. I hope you understood. So remember, this AB determines BC. What that means? Let's see what that means. That means like this. Whenever this AB combination is same, for example, if I put 1 2 1 2 here, If I put 1 to 1 to here, in these two tuples, AB combination is same, yes or no? In these two tuples, this is your T1 tuple, T2 tuple. In these two tuples, AB combination is same. So this BC combination also must be same. Is this clear? AB combination is same. So this BC combination also must be same. Is this point clear? Let me know. AB combination is same. So this BC combination also must be same. Understood? This BC combination also must be same. Okay. I hope you understood. For example, in this T3, if I do this, now tell me, do we have same AB combination? Do we have same AB combination? Please tell me. Here, do we have same AB combination? We don't have same AB combination. So now you can put anything. That does not matter. Okay. So you can see whenever AB combination is same, then BC combination must be same. So that's it. So this is the idea. So remember, this functional dependency you can define for set of attributes also. You can define for set of attributes also. Okay, what this means? Let me know. This AB determines D. What this means? Please tell me. This AB determines D. What this means? This means that set of attributes ABC. This is set of attributes ABC determines set of attributes D. Okay. And what this means? That whenever this combination is same, then this combination must be same. Okay. Whenever this combination ABC, DE, whenever this combination is same, for example, 1 to 1, 1 to 1, whenever this combination is same, then remember this DE combination also must be same. Okay. Is this clear? Very simple point. But if you change this AB combination, then this DE combination can be anything. Now you can put whatever you want. Okay. Now you can put whatever you want. Is this clear? Please tell me. Now you can put whatever you want. So I hope you understood all these points. Is this clear? All of them. All these points, are they clear? So this is the complete concept of functional dependencies. Okay. So we will just use ABC. But what it means when I simply use ABC, what it means set containing ABC. Is this clear? Whenever I say ABC, that simply means set containing ABC. But this is the notation we will use. This ABC notation we will use because this is more convenient. Okay. This is more convenient. So we have seen what are the definition of functional dependency. Okay. So you can see A1 to AN functionally determine B1 to BM. When it will happen? Please tell me. A1 to AN. Okay. This set functionally determines B1 to BM. When this will happen? This will happen whenever this combination is same, this combination must be same. If you repeat this combination, then you should repeat this combination also. Okay. So this is the simple concept. So you can see, okay, you can see whenever this A combination is same, then this B combination must be same. This is the concept of functional dependency. This is the definition of functional dependency that we have already seen. Now let's move on. Tell me the answer for this question. Let me know the answer for this question. See, this question is given to you. Assume that following functional dependencies hold. This is already given to you that the following functional dependencies hold. What this means? When you say these functional dependencies are they holding for an instance or are they holding for a schema? Please tell me. See, we are saying the following functional dependencies hold. These dependencies, they hold. Then what we are saying? Yes, we are saying that they are holding for a schema because functional dependencies are defined for a schema. Agree or not? Yes or no? Is this clear? Please tell me. Functional dependencies are defined for schema or instances? Let me know. Functional dependencies are defined for schema, not for instances. So remember, functional dependencies, these are defined for schema. These are integrity constants. Functional dependencies are integrity constants. Okay. And all integrity constants are defined for schemas. All integrity constants are defined over schema. Over schemas. Okay. Not on instances. Not over instances. Is this clear? So remember, these functional dependencies, these are also integrity constants. These are also integrity constants. And what I can say that all integrity constants, they are defined over schema. Okay. So very simple point here. These functional dependencies, they hold on the schema. Now the question is asking, can the following tuples coexist? Can the following tuples coexist? Please tell me. Can they coexist? This type of table can you get? If you have this functional dependency, then can you get this type of table? Please tell me. If you have these functional dependencies on the schema, you have these functional dependencies, then can you get this type of instance? This instance you cannot get, right? Yes or no? This instance you cannot get. Why? What is the reason? What is the reason? Because notice, title determine department. If title is same, then department must be same. Yes or no? If title is same, then department must be same. Is it happening? Is it happening? No, it is not happening. Yes or no? So very simple point, that title determines department. You can see title determines department. Okay. So if title is same, then department must be same. If you have same title, then department must be same. But that's not happening. So remember, this instance is not possible. Yes or no? So I can say this instance is not possible. This instance is never possible. So very simple point. This instance is never possible. Is never possible. Okay. DBMS will not allow this type of instance. Okay. DBMS does not allow this type of instance. I can simply say DBMS prevents. Okay. DBMS will prevent it. Okay. DBMS will prevent this instance. This instance will not be allowed by DBMS. Error will come. Okay. If you try to do this, if you try to insert these tuples, remember, if you try to insert these tuples, these three tuples, if you try to insert, then DBMS will prevent. DBMS will give you error. Okay. Now, this we have already seen that functional dependencies, these are defined on the schema. So all the instances, they must satisfy them. All the instances, every instance must satisfy them. This I told you. Okay. So given an instance, you can check if functional dependency holds or not. If I give you some instance, then you can check for this instance, some functional dependency holds or not, that you can check. But remember, if you want to say that on the schema, the functional dependency will hold. This functional dependency will hold on the schema. What that means? That means all the instances must satisfy this dependency. Is this clear? Okay. So if you want to say that some functional dependency holds for schema, that means that all the instances, every instance, remember, every legal instance should satisfy that functional dependency. Okay. So now you tell me the answer for these. Tell me the answer for this one. So these we have already seen. Okay. So you don't have to check these. Just check the remaining. Tell me. This instance is given to you. The question is asking which FDs hold on this instance. The question is asking for the instance. Which functional dependencies they hold for the instance. What this means? This means AB. If AB combination is same, then C combination should be same. Is it happening? If I tell you what is the value of AB combination, can you tell me the value of C? If I tell you the value of AB combination, then can you tell me the value of C? So you can see, whenever AB combination is repeating, then C is also repeating. Yes or no? Whenever AB combination is repeating, C combination is also repeating. You can easily see. Okay, here AB combination, please notice, here AB combination is same. Here and here, AB combination is same. You can see C combination is also same. So if AB combination is repeating, then C combination is also repeating. I can say whenever AB combination is same, then C combination is also same. So yes, this holds for this instance. What about AC determining B? What about AC determining B? What about this? AC determining B. Tell me, if you repeat AC, then is B repeating? If you repeat AC, no, B is not repeating, right? For example, if you repeat AC, notice. If you repeat AC, if I repeat this AC, for example, if I give you this 0404, then can you determine what is the value of B? Please tell me, can you determine what is the value of B? Let me know. I'm giving you the AC combination. The AC combination I'm giving you, that is 04. Now, can you determine the value of B? We cannot determine. We cannot determine. What about this BC determining A? What about this? BC determining A. Please tell me. If BC combination is same, then can I say A combination is also same? Yes. Yes, this is correct. Okay. So I hope this is clear. Now tell me, the same question is if I ask for the schema, the same question I ask for the schema, which functional dependencies hold? Okay, so you can see which of these functional dependencies hold, okay, and do not hold, and which do not hold on schema. Now tell me, I am asking for the schema. If the same question I ask for the schema, then what will happen? See, then you can say this, definitely this will not hold. Yes or no? Definitely this does not hold. I can say this does not hold on schema also. Okay, this does not hold on schema. What about the remaining? Okay, this does not hold on the schema. What about the remaining? The remaining we cannot say. Yes or no? The remaining, for example, this and this. For these two, we cannot say. We cannot say anything. We cannot say anything. For these two, we cannot say anything. Basically, they may or may not hold. They may or may not hold on the schema. May not hold on schema. Okay. So these, they may or may not hold on the schema. We cannot say anything. Is this clear? But definitely I can say that AC determining B, that will not hold. Yes or no? This does not hold. This AC determining B. Now let's move on. Tell me the answer for this question. Can I give you this question as a homework? Please tell me. This question, can I give you as a homework? So very simple question. Instance is given to you. You need to check which of the following functional dependencies are satisfied by the instance. The question is asking for instance or for the schema. Notice, which of the following dependencies are satisfied by the instance? The question is asking for the instance. Okay. Remember, the question is asking for the instance. So which functional dependencies hold for the instance? Can you tell me quickly? What about this? AB determining C. AB determining C. What about this? Quickly tell me. AB determining C. Whenever AB value is repeating, can I say C value is repeating? No. So this does not hold. Okay. Can you tell me about ABC determining A? Tell me. Can you tell me ABC determining A? What about this? ABC determining A. What about this? ABC determining A. What about this? Can this repeat? Please tell me. Only three attributes you have. Only three attributes you have. Can this repeat? This cannot repeat in the relational model. You can see this is never repeating. All the tuples, they will be different. Yes or no? No two tuples can be same. Agree with me? See, these are the three attributes ABC. No two tuples can be same. No two tuples can be entirely same. So very simple. This will hold. Yes or no? This will hold. No problem. Okay. So very simple. This will hold. This will hold. What about AB determining AC? What about that? Please tell me. What about AB determining AC? What about AB determining AC? Whenever AB value is same, can I say AC value is same? Whenever AB value is same, then can I say AC value is same? Whenever you have AB value same, can I say AC value is same? No. Okay. So the remaining you can check. Okay. Is this clear? So here you can notice the AB value is same. That is 6,2. That is 6,262. But what about BC value? But what about BC value? Sorry, what about AC value? But what about AC value? What about AC value? You can see AC value is 6,365. Okay, so you can see this does not hold. AB determining AC, this does not hold. Okay, so very easily you can do. So this question you can take as a homework. Now let's move on. So I hope you understood. Okay, so this is the note that is given to you. You can see here. This note is given to you that, remember, by looking at an instance, can you determine functional dependencies? By looking at an instance, notice, by looking at an instance, we might be able to tell which functional dependency do not hold, but we can never tell which does not hold. Which do hold. Yes or no? See this. Is this clear? Notice, by looking at an instance, if you look at an instance, then you can determine. See, you can determine that some functional dependency does not hold, but you can never determine if some functional dependency holds. Yes or no? Is this clear? Please tell me. So this is what we have already seen. You can see here. So you can read this. Very simple. Okay. A student is asking, last one same as AB determining C. That I will tell you. Okay. See, a student is asking, is this same as, tell me, this is same as, can I say this is same as AB determining C? Are they same? No, they are not same. They are different. They are different. Okay. But they are equivalent. See, they are different, but we will see that from here you can get here. Okay. That we will see. Don't worry. That will come in the future. But remember, these are different. This functional dependency, they are different dependencies. Is this clear? They are functional. They are different FDs. They are different FDs. Is this clear? So anyway, this will come in future. Don't worry. Okay. This I will teach you in the future, that if you have this dependency, then this implies this. Also, this implies this. Okay. Both of them. So remember, this will imply this. This will imply this. So that we will see. Don't worry. But they are different functional dependencies. These two functional dependencies, they are different. Okay. But they are equivalent. These are different, but they are equivalent. Okay. So that we will see in the future. Anyway, so let's move on now. This is your GATE exam question. Tell me the answer for this question. This is GATE Computer Science 2000 question. Consider the following relational instance. This instance is given to you. This instance is given to you. The question is asking, which of the following functional dependencies are satisfied by the instance? The question is asking for the instance or for the schema. Please tell me. This question, is it asking for instance or for the schema? This is asking for the instance. The question is asking which functional dependencies are satisfied by the instance. By the instance. Yes or no? Which functional dependencies are satisfied by the instance? By this instance, which functional dependencies are satisfied? So now tell me the answer. Now tell me the answer. Let's check one by one. XY determining Z. What about this one? XY determining Z. What about that? XY, does it determine Z? If you have same value for XY in two tuples, then can I say you have same value for Z in those tuples? Means whenever two tuples have same XY combination, then can I say those tuples have same Z value? Tell me. You can easily see that no tuples have same XY combination. So that is fine. Yes or no? If I give you the value of XY, can you tell me the value of Z? Can you determine the value of Z? See, if I give you the value of XY, this combination, if I give you, then can you determine the value of Z? Tell me. If I tell you the combination, this XY combination value, if I tell you, then can you determine Z? Can you determine Z? Tell me. For example, if I tell you XY is, if I tell you XY is 1, 4, then what will be Z? What will be Z? If I tell you XY is 1, 4, then Z will be 2. If I tell you XY is 1, 5, then Z will be 3. If I tell you XY is 1, 6, Z will be 3. If I tell you XY is 3, 2, then Z will be 2. So can you notice XY determines Z? Do you agree? XY determines Z. So yes, this will hold. Yes or no? For this instance, by this instance, remember, by this instance, XY determining Z holds. Okay, so this will hold. What about the next one? What about Z determining Y? What about Z determines Y? Will it hold? Z determines Y. Will it hold? You can see in these two tuples, look at the first tuple and last tuple. In these two tuples, look at this tuple and this tuple. Here you can notice the Z value is same, but the Y value, that is different. Yes or no? Y value is different. Okay. So if I tell you the value of Z, can you determine the value of Y? If I tell you the value of Z, now can you determine the value of Y? Please tell me. Let me know. If I give you the value of Z, now can you determine value of Y? We cannot determine. We cannot determine. Yes or no? Okay. Yes or no? We cannot determine. So remember, by this instance, I can say by this instance, what I can say by this instance, I can say this does not hold. Okay. Not satisfied. Not satisfied. Okay. This instance will not satisfy this. Okay. What about the remaining? So you can see option A, that is gone. Option A is gone. What about Y determining Z? What about Y determining Z? Can I say Y will determine Z? Yes, Y will determine Z, right? Yes or no? You can see Y will determine Z. Notice that Y value does not repeat. Okay, so automatically this will determine Z. Y value does not repeat. Because Y value does not repeat, so Y will determine Z also. Y will determine X also, because Y value does not repeat. So you cannot create a violation. You cannot create a violation. Tell me one thing. How to create violation of A determining B? What do you need? If you want to create a violation of A determining B, then what you need? What you need if you want to create a violation of A determining B? Then definitely you need this type of situation. See, this type of situation you need that two tuples have same A value, but they have different B value. Yes or no? Is this clear? Please tell me. So if you want to create a violation of A determines B, you must have this type of situation. You must have this type of situation. Is this clear? You must have this type of situation that if in two tuples you have same A value, but you have different B value. Okay, this type of situation must be there. If this type of situation is there, then violation. Okay, that implies violation of A implies B. Okay, is this clear? That implies violation of A implies B. This is the situation for violation of A implies B. Now you can notice, because Y value does not repeat, so is violation possible? Look at Y value. This Y value does not repeat. Notice, this Y value does not repeat. So can violation exist? Can you create violation for Y determining Z, Y determining X? You cannot create. Yes or no? So very simple. Y determines Z, Y determines X. Okay. What about YZ determining X? What about YZ determining X? Again, this value does not repeat. You can easily see this YZ combination never repeats because Y does not repeat. See, notice Y does not repeat. This Y value does not repeat. So this combination also does not repeat. Because this combination does not repeat, so you cannot create a violation for this functional dependency. For this functional dependency, you cannot create a violation. So I can say this also will hold. So can I say option B, that will hold, yes or no? Option B is correct. Option B, that is correct. Is this clear? Okay. So remember this point, this simple point, you understand that Y value does not repeat. So you cannot create violation for Y determining Z. Similarly, Y value does not repeat. So you cannot create violation for this functional dependency. Now remember, Y value does not repeat. So this combination also does not repeat. Now remember, if this combination does not repeat, then you cannot create violation for this functional dependency. Okay, so very simple. For this question, I can say answer will be option B. What about option C? What about option C? In option C, this X does not determine Z. Let's check. Can I say X determines Z? Can I say X determines Z? No, you can notice X does not determine Z. Yes or no? X does not determine Z. So option C is also wrong. What about Y determining X? That will hold. Y determining X will hold. But what about XZ determining Y? What about XZ determining Y? Please tell me. What about XZ determining Y? Can I say XZ determines Y? No, because you can easily see XZ13, XZ13. Yes or no? Look at these two tuples. Look at these two tuples. XZ is 13. But what is the value of Y? So you can see in these two tuples, XZ combination is same, but Y value is different. Okay, so what I can say, this is also not correct. So what is the final answer? The final answer is option B. Is this clear? The final answer is option B. So very simple point. Now let's move on. So we have seen the definition of functional dependency, the concept of functional dependency we have seen. Now the next topic is types of functional dependency. There are two types of functional dependency. One is trivial functional dependency, another is non-trivial functional dependency. These are the types of functional dependency. Now let's see what is the trivial functional dependency. Trivial, the name itself is telling you. Trivial. Trivial means this will always be true. Trivial functional dependency. Okay, trivial functional dependency. What is trivial? Let me tell you one thing. This will help you in every subject. This will help you in every subject. What is a trivial fact? Please tell me. What is a trivial fact? Trivial fact is which is either always true or always false. Okay, remember trivial. When can I say some statement is trivial? When can I say some statement is trivial? Trivial fact means either this is always true, either this is always true, either this will be always true, or this will be always false. Okay, either this will be always true or this will be always false. Is this clear? Okay, so this type of fact is called trivial fact. For example, if I say, man is man. Okay, now tell me, man is man. This is a trivial fact, yes or no? This will always be true, yes or no? This is always true. Man is man, dog is dog. Okay, I can say dog is dog. So you can see that these things are always true. So because this statement is always true, I can say this is trivial. This is trivial, right? This is trivial. Similarly, if I say dog is cat, okay, or I can say dog is not dog. Okay, if I say dog is not dog, if I say dog is not dog, now this is trivial. This is always false. Okay, so this is just an analogy. Okay, don't get into it. But I'm saying trivial fact. That means something which is either always true or something which is either always false. Either it will be always true or it will be always false. Now let's see what is trivial functional dependency. Trivial functional dependency. Now you consider this type of functional dependency. You consider A determining A. Can I say this will always hold in every relation? Whatever data I give you, whatever instance I give you, can you say this will always hold? Please tell me. Can I say that whatever instance I give you, whatever relation I give you, whatever relation I give you, whatever instance I give you, can I say this will always hold? Yes, this will always hold. Can you prove it? Can you prove it? Can you prove that this will always hold? See, this will always hold. Please note, this will always hold in every instance of every relation. Yes or no? This will always hold in every instance of every relation. So remember, this thing will always hold. This statement will always hold in every instance of every relation. So that is the reason this is called trivial. And can you prove it? Yes, very simple. See, in two tuples, if I give you the same A value, can you give me the value of A? If I give you the value of A, can you give me the value of A? Tell me. If I give you the value of A, then can you tell me the value of A? Yes. Yes or no? Agree? Very simple, right? Very simple point. If I tell you the value of A, I'm giving you the value of A. Can you determine the value of A? See what this means. See what this means. This means that given value of A, can you determine value of A? Given the value of A, given the value of A, can we determine value of A? Can we determine value of A? Yes, you can do that. Can we determine value of A? Okay. Yes, you can do that. Okay. Yes or no? So, for example, if I tell you that value of A is 4, then tell me, can you give me the value of A? I tell you value of A is 4. Then can you tell me the value of A? That will be 4. Yes or no? Is this clear? Please tell me. So remember, this type of functional dependency, this is a functional dependency, and this functional dependency will always be true in every instance of every relation. Yes or no? This functional dependency will always be true in every instance of every relation. Is this clear? Okay. Now you tell me about this type of functional dependency, AB determining A. What about this type of functional dependency? If I tell you the value of AB, can you tell me the value of A? Please tell me. Like, let me give you, given, I'm giving you the value of AB. I'm giving you the value of AB. Now, can you give me the value of A? Now find the value of A. Can you determine the value of A? What will be the value of A? Please tell me. I'm giving you the value of AB. Now, can you determine the value of A? Yes, you can determine the value of A will be. Yes, we can determine, and that value of A, that will be 1. Is this clear? So can you notice this is also trivially true. This will also hold. Again, this will always hold. Again, I can say this will always hold in every instance. In every instance of every relation. Yes or no? This will always hold in every instance of every relation. So this is trivial. This is also trivial because this will always be true. If I tell you the value of AB, can you find out the value of A? If I tell you the value of AB is 5, 5. Okay, I'm telling you the value of AB, that is 5, 5. Then what is the value of A? That will be 5. Yes or no? So if I give you the value of AB, can you determine the value of A? Yes, you can do that. So you can see this will always hold. So this is also trivial functional dependency. Okay, so very simple point. This is your trivial functional dependency. I can say this is the trivial functional dependency. Now, can you tell me what is the definition of trivial functional dependency? Similarly, this is also your trivial functional dependency. This is also trivial functional dependency. So can you tell me the definition of trivial functional dependency? Let me know. What is the definition of trivial functional dependency? Tell me. What is trivial functional dependency? Trivial functional dependency means X determines Y is a trivial functional dependency. This is trivial functional dependency if and only if this X is a superset of Y. This X is a superset of Y. Is this clear? Okay. This X is superset of Y. For example, here you can notice this AB, this is a superset of A. Yes or no? This AB, this is superset of A. For example, here you can notice this A, this is superset of A. So this is the definition of trivial functional dependency. Trivial functional dependency means X determines Y. This is trivial functional dependency if and only if X is superset of Y. Is this clear? Please tell me. This is the idea. X is superset of Y. Okay. So this type of functional dependency, this will be called a trivial functional dependency. Okay. And remember, trivial functional dependency always holds. Trivial functional dependency always holds. Always holds in every instance. In every instance. In every instance of every relation. Is this point clear? Let me know. Okay, so very simple point that this trivial functional dependency, this will always be true. This will always be true in every instance of every relation. So this is the concept of trivial functional dependency. Now tell me, when can I say a functional dependency is non-trivial? When can I say a functional dependency is non-trivial? Please tell me. What is the definition of non-trivial functional dependency? The name itself is telling you. Non-trivial means which is not trivial. Yes or no? FD which is not trivial. FD which is not trivial. Which is not trivial. The name itself is telling you non-trivial functional dependency means an FD. Okay, a functional dependency which is not trivial. For example, okay, so in simple words, I can say, when can I say X determines Y is non-trivial? Tell me. When can I say this is a non-trivial FD? When can I say this is non-trivial FD? Tell me. Let me know. I can say this is non-trivial FD if and only if X is not superset of Y. Yes or no? If and only if X is not superset of Y. Okay, then this will be called non-trivial functional dependency. Is this clear? Very simple point. So remember, if it is not trivial, then it is non-trivial. Is this clear? Let me ask you some questions. For example, let's assume R, A, B, C, D. Okay, this relation I'm giving you. Now you tell me which is non-trivial. Which FD is non-trivial? Some functional dependencies I'm giving you, and you tell me which of them is non-trivial. Which functional dependency is non-trivial? For example, let me give you some questions like A determining A. Let me ask you another question. A determining B. AB determining AC. A determining BC. A determining AB. AB determining CD. AB determining A. ABCD determining AB. Okay, tell me, which of them is trivial, which of them is not trivial? Let me know. Which of them is trivial, which of them is not trivial? Which functional dependency is not trivial? So you can see, this is trivial, right? Yes or no? This is trivial. This is a trivial. This is trivial, right? Agree? So you can see, this is trivial. What about this? This is also trivial. This is also trivial. Okay. You can see which is non-trivial. You can see this is non-trivial. because this is not superset of BC. This is non-trivial because you can see this this is not superset of AB. This is non-trivial. This is trivial. This is non-trivial. This is non-trivial. Is this clear? So which functional dependencies are non-trivial? The answer will be 2, 3, 4, 5, 6. Yes or no? The answer will be 2, 3, 4, 5, 6. 2, 3, 4, 5, 6. These are the non-trivial. Is this point clear? Please tell me. So very simple. Non-trivial functional dependency means a functional dependency which is not trivial. Okay, so this is the definition of trivial and non-trivial. So what is the definition of trivial? Alpha implies beta is trivial if alpha is superset of beta. Alpha is a superset of beta, or I can say beta is a subset of alpha. Yes or no? So alpha implies beta, that is trivial if and only if beta is a subset of alpha, or I can say LHS is a superset of RHS. Yes or no? LHS is superset of RHS. Remember, if you have this functional dependency, then this alpha will be called LHS and this beta will be called RHS. Is this clear? Please tell me. Is this clear? Now tell me, if I give you this functional dependency, now tell me who is LHS? Who is LHS? If I give you this functional dependency, who is LHS? Remember, this is same as B determining A. These are same. So remember, this B will be the LHS. Okay, so here remember, this is the LHS. And remember, this A will be the RHS. Okay, so very simple point. So remember, whenever you have a functional dependency, alpha implies beta, then this alpha will be LHS and beta will be RHS. Okay, so very simple point. So we have seen what is a trivial functional dependency. Trivial functional dependency means this is a subset of this. I can say this RHS is subset of LHS. Yes or no? RHS is subset of LHS. This is called trivial functional dependency. Otherwise, if a functional dependency is not trivial, then it is a non-trivial. Yes or no? So you can see this, that if a functional dependency is not trivial, okay, otherwise it will be non-trivial. Okay, so either a functional dependency will be trivial or it will be non-trivial. Very simple point. Now let me tell you one more concept that is given in Ullmann book. See, this is not given in other books. Only in the Ullmann book this is given. That is something called completely non-trivial. Okay, this concept is given in the Ullmann book. This concept is given in the Ullmann book only. This definition, this is just a definition, nothing else. Okay, this is given in only in the Ullmann book. This is not given in the Nawate. This is not given in Korth. This is not given in, I can say, Raghurama Krishna. But this is only given in the Ullmann. But this is also very simple. When can I say completely non-trivial? Completely non-trivial. That means LHS and RHS, they are disjoint. Completely non-trivial. What that means? That means LHS and RHS, they are disjoint. Means they have nothing common. They have nothing common. This will be called completely non-trivial. Okay, so this is just a definition, nothing else. So you can see trivial means, what trivial means? Trivial means these B's, these are subset of A's. Non-trivial means that it is not trivial. Okay, non-trivial, that means it is not trivial. And what is completely non-trivial? That means LHS and RHS, they have nothing common. Is this clear? See, what is the definition of trivial? Please tell me. If I give you a functional dependency, X determining Y, when can I say it will be trivial? Let me know. When can I say it will be trivial? When can I say this is trivial? This will be trivial if this LHS is superset of RHS. Okay, very simple. When can I say this is non-trivial? When can I say this is non-trivial? When can I say this will be non-trivial? Non-trivial means X is not superset of Y. Yes or no? Simply, in simple words, not trivial. Okay, in simple words, I can say not trivial. And when can I say it is completely non-trivial? When can I say it is completely non-trivial? When can I say that it is completely non-trivial? When can I say that it is completely non-trivial? This we will say that when X intersection Y is empty, when they have nothing common. They have nothing common. X comma Y are completely disjoint. Okay, that means X comma Y have nothing common. Have nothing common. Okay, so their intersection is phi. In this situation, we will call it completely non-trivial. So these are the three definitions. Okay, quite easily you can see. Okay, so very simple. Now let's move on. Now let's see this question. Tell me the answer for this question. What is the answer for this question? Regarding trivial functional dependencies, which best describes completely non-trivial? The question is asking for the definition of completely non-trivial. So what is the definition of completely non-trivial? If a functional dependency x to y holds where x intersection y is phi. Yes, this is the definition of completely non-trivial. Yes or no? This is the definition of completely non-trivial. Tell me, this is the definition of what? This statement, if a functional dependency holds where y is subset of x, this is your trivial functional dependency. This is your trivial functional dependency. What about this last one? What about this last one? Tell me. This last one. What about the last one? The last one is non-trivial. The last one is non-trivial. This is non-trivial functional dependencies. Okay. And this middle one. What is this middle one? This is your completely non-trivial. This is your completely non-trivial. So can I say this is non-trivial also? Can I say every completely non-trivial that is non-trivial? Every completely non-trivial is non-trivial also? Yes, of course. Yes, of course. Right. Okay. So remember, this is non-trivial also. This implies non-trivial also. Okay. This implies non-trivial also. Okay. So very simple point. So this is the definition of trivial. This is the definition of non-trivial. And this is the definition of completely non-trivial. So this is the idea. Okay. Let's move on now. Now I want to tell you one thing. A misconception I want to tell you. Maybe some of you have seen this word semi-trivial. Have you seen this word? Maybe you have seen this word on the YouTube or maybe in some other non-standard resources. Okay, maybe you have seen this. In some coaching institute, maybe you have seen this. So let me tell you, this does not exist in the standard resources. This semi-trivial. No such concept exists in standard resources. So this is not a standard concept. Okay. So anyway, I'm just, see, some students are saying that they are reading DBMS for the first time. That is good. Okay, that is good. Whatever I'm teaching you, I'm telling you, I'm teaching you from the standard resources. For every concept, I'm giving you multiple, I can say, screenshot of standard resources. Ullman, Nawate, Korth, Ragurama Krishna. Okay, all the standard resources we are covering. But I'm telling you that in some coaching institutes, this type of concepts are taught. Okay, this semi-trivial functional dependency, this is taught. But let me tell you, no such concept exists in any standard resource. There is no standard resource containing this type of concept. Okay, so very simple point. Okay, this semi-trivial functional dependency, this type of concept does not exist in the standard resources. Okay, so whatever we have seen, that is from the standard resources. Trivial functional dependency, non-trivial functional dependency, everything that we have seen. Okay, is this clear? Let me know. Now, one more topic, one small topic, that is another notation for functional dependencies. This is another notation. This is another way of, I can say, describing the functional dependency. What is this another notation? This is just a notation, nothing else. Remember, this is just an alternative notation for functional dependency. What this notation says? This notation says that, see, if you have this functional dependency A determines B, then you can describe this like this. See, okay, A, B, C, D. What you can do? You can put like this, that A like this. Okay, see, very simple. This is just a notation. These two things are same. These two things are same. For example, if you want to describe A determines BC, how will you do that? If you want to describe A determines BC, how will you do that? This LHS you will do like this. And for the RHS, you will put the arrow. Okay, for the RHS, you will put the arrow like this. Is this clear? This is just a notation. This is just an alternative notation, nothing else. Please tell me, did you understand this? This is just an alternative notation that this functional dependency you can represent like this. Okay, so what is happening here? See what is happening. Means basically I'm saying that LHS implies RHS. This you can denote like this. In LHS, let's assume you have, for example, in LHS, let's assume you have AB determining, let's assume CD. Okay, let's assume you have AB determining CD. Then how will you denote it? Then how will you represent it? A, B, C, D, E. How will you represent it? Very simple. This is your LHS, right? This is your LHS. So for this LHS, you will use without arrow. Okay, you will use it without arrow. You will show it without arrow. Okay, you will show it without arrow. You will be shown. Okay, without arrow, show without arrow. What I can say? I can say that show this without arrow. Show without arrow in this notation, in this alternative notation. Alternative notation. Okay, so in this alternative notation, this LHS will be shown without arrow. Okay, for the LHS, you don't have to put the arrow. And for the RHS, you will put the arrow. Okay, show with arrow. Show with arrow. So this is the notation. See what will happen. This is how you will do. So this is how you will do. Okay, so something like this. Or what you can do, something like this, you can do that. Like this, and then you will put arrow here. Is this clear? Please tell me. Is this understood? Let me know. So like this, you can denote. So remember, this you will put without arrow, and this you will put with arrow. Is this understood? Okay, so very simple. For example, let's see this. If this diagram is given to you, then what are the functional dependencies? If this diagram is given to you, then what are the functional dependencies? From this diagram, what are the functional dependencies? Functional dependencies in part A. What are the functional dependencies? For example, look at this. See, this is without arrow, right? Yes or no? This is without arrow. Correct? This is without arrow. So what that means? This is without arrow. And these are arrow, 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 arrow. Okay, so what I can say? I can say SSN determines these four things. Yes or no? Okay, SSN determines these four things. So remember what this will mean. What this entire thing, what this means. This entire thing. Look at this entire thing. Okay, this entire thing. What this means? This means that SSN determines. This is LHS. Basically, this means LHS. This means LHS. And these arrows, these are RHS. So I can say SSN implies ename, okay, ename, comma, B date, birthday date, comma, address, and comma, D number. Okay, so like this. So this is your functional dependency. Is this clear? Let me know. Very simple, right? Yes or no? So remember, this without arrow, this is your LHS. And this arrow, these are your RHS. So like this, you can say. Okay, so this is how you can do. So very simple. So this means SSN implies this SSN. This implies these things. Okay, what about this next one? What about this one? See, what about this one? Look at this and tell me. What about this one? Here you can again notice, this is without arrow, right? This is your LHS. There is no arrow. Okay, these are not connected. See. Okay, this is separate. It's not connected. Is this clear? These are separate. Okay, this, look at this. Look at this. This is separate. So here you can see that what this will be. This will be that D number. I can say D number implies what? D number implies D name, comma, D manager name, D manager surname, SSN, D manager SSN. Okay, so this is the meaning. I hope you understood. Similarly, can you do for the next one? For the next, how many FDs are there in the second one? In the second one, how many FDs are there? Look at the second one. There are total 3 FDs. Okay, what is the first FD? Okay, let's look at this second one. In this, what is FD number 1? FD number 1, what is that? That is your LHS is this. LHS is a combination of SSN, comma, P number. Yes or no? Combination of this implies hours. Okay, very simple. What is your FD number 2? What is your functional dependency 2? That is SSN implies ename. SSN implies ename. Okay, what is your FD number 3? What is your FD number 3? That is P number implies. That is P number implies P name, comma, P location. Okay, so is this clear? Let me know. So you have 3 functional dependencies: FD1, FD2, FD3. So this is your alternative notation. Nothing else. Very simple. This is very simple. Okay. So this is your diagram notation. You can read. Okay. You can check it. Now tell me the answer for this one. What are the functional dependencies? In this, you find functional dependencies. How many functional dependencies are given in this diagram? How many functional dependencies are given? Find functional dependencies. So tell me, what are the functional dependencies given by this diagram? So you can see this functional dependency. Tell me what is this functional dependency. Let me know. This functional dependency is AB determining C, D, E, F, G. Yes or no? AB determining C, D, F, E, F, G. This is your functional dependency. What is this functional dependency? This functional dependency, this is your A determining D. What is this functional dependency? This is your E determining G. Okay. And finally, what is this functional dependency? This is your C determining B. Okay. Understood? So this notation, is this notation clear? Please tell me. This notation, is it clear? Okay. So let's solve this question. Tell me the answer for this question. A very nice question to help you understand what is functional dependency. What is the meaning of functional dependency? Understand the meaning of functional dependency. So there is a relation apply, application form, okay. So like, for example, when you will apply for the colleges after the GATE exam, you will apply for the colleges counseling. You will do the counseling, right? Okay. So this is your apply. Now, SSN means student serial number. Okay. This is your student serial number. This is like Aadhaar card number, something like that. Okay. This is your student serial number. So I can say this is like your Aadhaar card number. So you can say this is your student serial number. This is unique, right? Okay. So anyway, so this is your student serial number. Next, this is your college name. What is the C name? This C name. This is your college name. This is your college name. Okay. Now the question is saying which real world situation is captured by this functional dependency? Which real world situation is captured by this functional dependency? This functional dependency is given to you. Now tell me, which real world situation is captured by this functional dependency? Tell me what this functional dependency says. When you say that SSN college name, this combination determines date. Okay, means if this combination is same, please understand, if this combination is same, then date will be same. If this combination is same, then date will be same. What that means? What that means? For example, let's assume okay, let me take Mohit. Okay, for example, Mohit is applying. Okay, let's assume Mohit is applying for IIT Bombay. Okay, college name is IIT Bombay. Okay, Mohit applies for IIT Bombay. Now, in IIT Bombay, for multiple courses, you can apply. Yes or no? You can apply for multiple courses. Agree with me? Okay, for multiple courses, you can apply. For example, let's measure. You can see this is your measure that is given to you. Okay, measure. So, for multiple courses, you can apply. Now, what Mohit is doing, for computer science also he applies. Okay, for maybe I can say for artificial intelligence also he applies. Okay, okay, maybe he also applies for, I can say, computer CDS. Okay, so in IIT Bombay, I think there is no CDS, that is in ISC Bangalore. Anyway, so you can see Mohit applies for IIT Bombay. Now you tell me, this combination, whenever this combination is same, date must be same. Agree with me? Do you agree with me? Do you agree with me that whenever this combination is same, if this combination is same, this combination is same, so this date must be same. This date, this must be same. So, okay, so let me say, like, for example, 4 April. Okay, so you can see something like this. I hope you understood. So you can see that. So from here, what I can say? From here, what I can say? I can say that for a particular college, a particular student can apply in all the courses on a fixed date. Yes or no? Means if you take a student you take and a college you take, if this combination you take, student plus combination, student plus college, this combination you take. Now, for this combination, all the application forms, they must be submitted on the same date. Yes or no? Do you agree with me? Yes or no? So remember, if Mohit wants to apply for IIT Bombay, then he has to apply for all the courses. He has to apply on the same date. Do you agree? Is this clear? Please tell me. This is the meaning. Yes or no? So I can say that every application form from a student, see, every application from a student to a specific college must be on the same date. This is the answer. Answer is option D. Is this clear? Let me know. Now, can you give me a situation which will violate option ABC? Can you violate option ABC? Let's try to violate option ABC. See, option A is saying a student can only apply for one college. Nothing like that. Yes or no? Nothing like that. You can apply for multiple colleges. You can apply for multiple colleges. For example, Mohit can apply for ISC Bangalore also. Okay, for ISC Bangalore, for computer science, he can apply. Okay, on some other date or maybe same date, does not matter. Okay, on same date also you can apply. But the point is that same student can apply for different colleges. Yes or no? Is this clear? Let me know. So very simple point. So I can say option A, that is gone. Option A is gone. Is this clear? A student can only apply for one college. That is not correct. What about this one? A student can apply to each college only once. Is this true? Is this true that a student can apply to each college only once? No. You can notice Mohit can apply for IIT Bombay 3 times, but on the same date. Yes or no? You can apply 3 times, but on the same date. The date must not change. Yes or no? You should not change the date. So Mohit can apply for IIT Bombay 3 times, 4 times, any number of times, but on the same date. The date must be same. Okay, because for this combination, the date must be same. If this combination is same, then this value must be same. So this is the idea. I hope you understood. So option B, that is also gone. Okay. Now what about option C? A student must apply for all colleges on the same date. A student must apply for all colleges on the same date. That is also not correct. For ISC Bangalore, you can apply on 10th April. For IIT Bombay, you can apply on 4th April. Yes or no? So this is the idea. Is this clear? Okay. Now, let me tell you, actually, normally it happens that ISC forms will come before IIT Bombay forms. Okay. So application form of ISC Bangalore, that will come before your GATE result. Okay. So before your GATE result, remember, when your GATE result will come, before that ISC application forms will be out. Okay. So anyway, now let's move on. Let's see this. Tell me the answer for this question. Tell me the answer for this question. Consider a relation A, B, C, D, E with functional dependencies. These are the functional dependencies that are given to you. Suppose that there are at most 3 different values for A, B, and D. There are at most 3 different values for A, B, D. What is the maximum number of different values for E? Okay. The question is saying maximum 3 different values you have for A, maximum 3 different values for B, maximum 3 different values for D. Now the question is asking maximum how many different values E can have. Is this clear? Did you understand the question? That A can have maximum 3 different values. B can have maximum 3 different values. And D can have maximum 3 different values. Now the question is asking that how many maximum different values E can have. So let's see this. These functional dependencies are already given to you. Okay. So first you check for C. How many maximum different values C can have? Tell me. See, very simple point. This relation is given to you A, B, C, D, E. Okay. And this functional dependency is given to you A, B determining C. First you tell me how many different values C can have. Now this is my question. Maximum how many different values C can have? Maximum how many different values C can have? This attribute C can have. Tell me. Maximum how many different values C can have? Tell me. See, very simple point that notice this functional dependency is given to you. Okay, this functional dependency is given to you. This A, B, C, this functional dependency is given to you. So what you can do for different combinations, you can put different values. Yes or no? I want maximum number of values for C. What I want, please understand. I want maximum different values for C. I want different values for C. Remember what I want. I want different values for C. Okay. Now you tell me one thing. This functional dependency is given to you. If I give you two different combinations, I am giving you two different combinations. Is it mandatory C must be different? Is it mandatory C must be different? Please tell me. Is it mandatory C must be different? Okay, it is not mandatory. C may or may not be different. Yes or no? For different combinations, this C can be same or this C can be different. Okay, these are different combinations. So this C can be same or different. Yes or no? This C can be same or different. But what I want, see, this C can be same or different. But what I want, tell me. But what I want maximum different values. So what I will do? I want maximum different values. Okay, remember what I want. I want maximum different values for C. Okay, so this is what I want. I want maximum different values. This is the important part. So what I will do, I will make sure that C has different values. So for every combination, I will put a different value. Okay, for this combination, different value. For this combination, different value. Okay, for this combination, different value. Is this clear? For every different combination, I will put a different value. For this combination, different value, and so on. So tell me, how many different combinations of A, B are there? Okay, and so on. You can see, and so on. Okay, you can easily see how many different combinations for A, B. Please tell me. Like this, you can create combinations for A, B, A2, B2, A2, B3, then A3, B1, and so on. Right? Yes or no? Is this clear? So tell me, how many different combinations are there for AB? This AB, this has 3 into 3 different combinations. These many different combinations are possible. Clear? Yes or no? That means 9. 9 different combinations are possible. Because A has 3 values, B has 3 values. This is already given to you in the question. That A has 3 different values. Maximum 3 different values for A. Maximum 3 different values for B. So they have 3 different values. Now I can simply say, so they have total 9 different combinations. Yes or no? Total 9 different combinations are there for AB. So total for C, how many different values possible? 9. Yes or no? So I can say maximum 9 different values possible. 9 different values possible. Values possible for C. Okay. For this C, maximum 9 different values are possible. Now, the question is asking for D. And remember, this CD determines E. CD determines E. And the question is asking for E. Okay, the question. You can see the question is asking for E. So tell me, what will be the answer? Now you can easily see this CD determines E. This combination determines E. Now you can see this has 9 different values. Yes or no? This has 9 different values. This has 3 different values. So how many different combinations are possible? So tell me, how many different combinations are possible for CD? How many CD combinations are possible? Please tell me. So you can see 9 into 3, that will be 21. Okay, 9 into 3, that will be 27. 27 different combinations are possible. Yes or no? Different CD combinations possible. CD combinations possible. These many different CD combinations are possible. So tell me, how many E values are possible? How many E values are possible? For every combination, you give a different value. For every combination, you give a different value, E1, E2, and so on. Okay, for every combination, what you will do? You will give a different value. So very simple. So finally, here answer will be maximum 27 different values possible. Okay, so this is your answer. So for this question, the answer will be 27. Is this understood? So this is another very simple question, but I hope you understood the concept of functional dependency. Is this clear? The concept of functional dependency, is this clear? Please tell me. Everything that we have seen so far, is that clear? Every concept. Did you understand what is functional dependency? What is trivial functional dependency, non-trivial functional dependency? Functional dependency is defined for the schema. Functional dependency is not defined on the instance. Okay. Remember, if you say that functional dependency is satisfied by the schema, then it means all the instances will satisfy functional dependency. Okay, remember functional dependency or any integrity constant, they are defined on the schema. Okay, so very simple, all the concepts we have seen. In the next lecture, we will study rules for functional dependencies. So this topic we will study in the next lecture. Okay, thank you everyone.